So we said that a statement can be either true or false. In a lot of cases, when we're just looking at the form of the logic, we actually don't care whether the statements we're talking about are true or false. We're just interested in the relationships between them. This is a lot like in algebra. When we're manipulating a variable, we often don't care what number the variable represents. Somewhere that variable does represent a number, but a lot of the manipulations we do will work no matter what number that variable represents. That's part of the point of algebra. Part of the point of formal logic is that there are certain manipulations we can do and certain inferences we can draw, whether or not the statements that we're working with in the background are true or false. So we're going to write down statements kind of regardless of whether or not they're true. So some examples of true statements. We could say 2 plus 2 is 4. That's true. 2 plus 2 really is 4. Anchorage, Alaska is further north than Springfield, Illinois. Again, that's true if you look at a globe. Anchorage, Alaska is on a further north line of latitude. If it's raining outside, there's water falling out of the sky. That is certainly true. That's what it means to be raining outside. There are also false sentences. 2 plus 3 equals 4. 2 plus 3 definitely does not equal 4. It equals 5, right? That's false. San Antonio, Texas is further north than Portland, Oregon. That is false, right? San Antonio, Texas is on a further south line of latitude than Portland, Oregon is. If it's raining outside, then it's also at least 70 degrees Fahrenheit. Again, not true. If it's raining outside, it might be 70 degrees Fahrenheit, it might not. Telling you that it's raining outside doesn't tell you anything about the temperature, at least not relative to 70 degrees. And there are also some statements that are definitely true or false, but we don't know which. So 2 plus x equals 4. Remember, in algebra, x always represents some number. So 2 plus x equals 4 is true if x represents the number 2, and it's false otherwise. We don't know which because we don't know what x represents. You are further north than Rome, Italy. Well, I don't know where you are when you're watching this video or when you're reading this lecture guide. So this depends on where you are when you watch this. And I don't know where you are when you watch this. And furthermore, you might watch this video at one time and have it be true, and at another time and have it be false. Another statement that we can't know whether it's true or false is, it will rain on April 29th, 2057 in Madrid, Spain. We can't predict this far in advance, but it will definitely either rain or not rain. So these are examples of statements that are definitely either true or false. But we don't know, and in fact can't know, which one they are. And we tend to use a lot of this kind of statement in formal logic because we're going to be interested in, well, what would happen if it was true? And what would happen if it was false? Just like in algebra, we like to do manipulations that will continue to work no matter what number our variable represents. In formal logic, we like to do manipulations that will work regardless of whether or not our sentences are true. In formal logic, we like to do manipulations that will work regardless of whether or not our statements are true.